Hi, so in this video, I'm going to continue for the discussion for the rest of the questions. So this is the questions which related to the number of moles of the atoms. So let's look at this question. Which of the following gases contain 1.2 mole of the atoms at the room condition? So it's given that 1 mole of the gas occupies 24 dm cube at room temperature. So this is actually the molar volume. So since in the options A, B, C, D is given the volume of the gas and we are provided with the molar volume, it means that we can actually find the number of mole of gas. So the number of mole of gas is equals to the volume of the gas divided by the molar volume, where in this case all the volume of the 4 types of gas is actually the same, which is 14.4, and then divided by 24 we will get 0.6 mole of gas. So next, actually we want to know which gas contain 1.2 mole of the atoms, right? So we need to know the number of atoms in the gas. However, in this question, it requires us to find which gases will contain 1.2 mole of the atoms. So actually these atoms we need to refer to the number of atoms in the gas. So hence it requires you to know how many atoms are there in one type of the gas. So let's say for the example, which is carbon dioxide CO2, it has 1 carbon and 2 oxygen. So it has actually 3 atoms altogether. So in order to find the number of mole of atoms it contains, we need to times this 3 with 0.6, which is equal to 1.8 mole. So since goes to this question, which is the nitrogen gas N2. So since it contains 2 nitrogen, so the number of mole of atoms is actually 2 times 0.6, which is 1.2 mole. So the answer is B. But let's continue for the question for the option C, which is this is a methane gas and it contains, and the chemical formula is CH4. So actually it contains 5 atoms because it contains 1 C and 4 hydrogen atoms. So altogether is 5, and times with 0.6 mole we will get 3 mole. Lastly, for the argon, it is actually a monoatomic gas. So it means that it contains one type of the atom in the gas. So the number of atoms for it will be 0.6 mole. So the answer would be B. So let's proceed to the next question. So this is a diagram that shows the apparatus set up to prepare the sodium hydroxide solution through the dilution method. So this is actually how we are going to prepare for standard solution. So we have this distilled water, and then this is for before. So before that we have the distilled water and 1.5 mole per dm cube sodium hydroxide solution. Then after we add the distilled water inside, and then we will get 100 cm cube of 0.6 mole of the sodium hydroxide solution. So we can actually know that, so we can observe that, so before the dilution, the concentration of the sodium hydroxide solution is 1.5, but after the dilution, the concentration of the solution is 0.6 mole, where it is actually shows that the concentration decrease, right? The concentration will decrease. The concentration of the solution will decrease. Okay. So we have one superpower formula, which is N1V1 equals to M2V2. So N1V1 is the initial and M2V2 is the after. So the question is asking what is the volume of the distilled water needed to prepare 0.6 mol per dm³ sodium hydroxide solution. So this is our final. So this 100 is actually our final volume. So we just put the amount inside, and then which is 1.5 times V1 equals to 0.6 times 100 cm³ of the concentration, and then we get V1 is actually equals to 0.6 times 100 divided by 1.5, so which is equal to 40 cm³. But in this question, it provides us with dm³, right? So in order to do the unit conversion, we need to know that dm³ to cm³. Basically, we need to convert it. When we want to convert dm³ to cm³, we need to times 100. So if we want to go for cm³ to dm³, we need to divide it by 1000. Sorry, it's 1000. So actually this 40 cm³ is also equal to 0.04 dm³. So this volume that we get is actually the volume for the volume of the NaOH, which is the initial volume of the sodium hydroxide that we need. So the question is asking volume of the distilled water. It means that this is actually like inside this, we don't know, we get this 0.04 dm³ for the volume of the NaOH that we put. So it means that in this beaker, right, we have 0.04 dm³ of volume of 1.5 mol per dm³ sodium hydroxide solution. So actually we want to find what is the volume inside the distilled water. So we know that the final volume is actually 100 cm³, right? Which is equal to 0.1 dm³. So the volume of distilled water needs is 0.1 minus 0.0504, which is equals to 0.06 dm³. So the answer would be B. So let's continue for the next question. So this question shows us the standard representations for the atom X and Y. So what is the relative molecular mass of the compound formed between the atom X and Y? So this is how the standard representation for the atom, right? So the proton number will always referring to the proton number. So this proton number is also telling us that what is the number of the electrons. But basically you can just refer to a periodic table and you will know that this atom X is actually the hydrogen. And then the atom Y will be the nitrogen. So the compound formed between the X and Y is actually ammonia, which is NH3, which is also known as YX3. So the reason why I know the compound formed between X and Y is ammonia is because so the X is still left one electron to achieve its duplet electron arrangement, and then for Y the electron arrangement for it is 2.5. So it still left 3 valence electrons to achieve stability. So you just write 3 on top of the y and x and 1 on top of the x. Then we cross it, we will get x3y, which is also yx3 for the ammonia. So we are just going to identify what is the relative molecular mass, and we know that the upper part of the number is actually referring to the nuclear number, and this nuclear number is actually telling us the relative atomic mass. So for ammonia, we will get 14 plus 3 bracket 1, which is, it means that we have 3 hydrogen atoms. So the answer will be 17, which is A. So next, for the next question, diagram 35. So this is the graph that shows the reaction between the sulfuric acid H2SO4 and the zinc, excess zinc, in the two experiments set 1 and set 2. So we just use 2 color. So the first one is represent for the set 1, and then we have this blue color for X2 for set 2. So by comparing the rate of reaction between 1 and 2, actually 2 will have the rate of reaction is higher. Higher than the set 1. So we are going to find which changes explain the difference in X and in set 1 and set 2. So let's go through the option one by one, A, B, C, and D. So A, catalyst is added in set 1. No, the answer should be in set 2 because the rate of reaction is higher. And for information, catalyst is actually like it will speed up the rate of reaction. Okay, and then for B, zinc granule is used in set 2. It should be zinc powder instead of zinc granules. Okay, so if it is zinc granules, it means that it is used in set 1. And then C, the higher temperature of sulfuric acid is used in set 2. The answer is C, because higher temperature means that it will have more kinetic energy, so the rate of reaction will also increase. And then D, higher concentration of the sulfuric acid is used in set 2. This is not correct because no matter how is the concentration of the sulfuric acid, it will still contribute the same number of moles of the hydrogen ion, unless today it changed it removed the words of the concentration and then it changed the sulfuric acid to the hydrochloric acid. Or we can say it changed to the sulfuric acid, then this will be the correct answer. So let's continue for the discussions of this question. So this is a question, so it shows that this is So let's continue with the discussion of the question. So this is a diagram that shows the apparatus set up for the experiment. And in this simple experiment, we have the acidified hydrogen peroxide and the potassium iodide solution. So let's write what the chemical formula for the hydrogen peroxide, which is H2O2, and the chemical formula for potassium iodide will be Ki. So we are given the reactions of the half cell and we are provided with the E0 value as well. So actually this is a redox reaction. So redox reaction means the oxidation and the reduction reaction will occur at the same time. So since it involves the oxidation and reduction, so for sure we also have the oxidizing agent and the reducing agent. So actually there is a very important information provided by the E0 value where it tells us what substance will going to be the oxidizing agent and what substance will going to be the reducing agent. So in this E0 value, this is also one of the methods that I always like to remember, which is the E0 value which is more positive. It will tend to undergo reduction. Yeah, so okay, for this E0 value we have let's say we have A and B. So which E0 value will have a more positive value? So the answer is positive 1.77, which is the hydrogen peroxide. So it means that this hydrogen peroxide will tend to undergo reduction, isn't it? So please remember also that when a substance tends to undergo reduction, opposite to it will be oxidizing agent. So for sure, it will be the oxidizing agent for the iodine. So for a less positive E0 value, it means that it will tend to undergo the oxidation. So since it undergo oxidation, so opposite to it, it will be the reducing agent. So just that simple. So we are going to identify what is correct about the statement. So let's go through one by one. So A, iodide ion is reduced to the iodine molecule. So based on the E0 value, we know that this iodide ion is actually tends to undergo the oxidation, right? So it means that it should be oxidized, where the chemical formula, the half equation for it will be 2I negative equals to 1 molecule of the iodine with 2 electrons. So B, oxidation number of the oxygen decreases from -1 to -2. So actually it's asking us to find the oxidation value, isn't it? So actually we focus on this H2O2 and the water. So let's calculate for it. So this is before. Okay, this is before. So before we have 2 positive 1 because the charge carried by the hydrogen ion is +1, and then we need to +2 because we have the 2 oxygen atom, and the oxidation number for oxygen, we let it be X, which is what we're going to find, so equals to 0. So we have positive 2 plus 2X equals to 0, and then we move it aside. Just solve for the X, so X will be -1. So okay, it is decreases from -1. So let's calculate for the after. So after, okay, so we have 2 water molecule and the 2 charge is because the hydrogen ion, and plus the 2X equals to 0 because we have 2 oxygen atom as well. So our answer would be -2. So this is the correct statement B. But let's continue to look at what is wrong with C and D. So C, the hydrogen peroxide is actually the oxidizing agent, right? As what we already analyzed for the question, so it is an oxidizing agent. So D, color of the solution changed from brown to colorless. But since this is the equation that we write, isn't it? 2I negative become the I2 and 2E. So this iodide ion is actually colorless. And then the iodine molecules is actually brown color. So the color changes supposed to be colorless to brown. So it is wrong for this question, for this statement. Okay, so let's continue for the next question. This question shows us the apparatus setup for a chemical cell. So we have magnesium, we have silver, we have magnesium and we have silver, and we have the porous part, okay, together with the 1.0 mole per dmq magnesium sulfate solution and 1.0 mole dmq silver nitrate solution. Same goes to the previous question. We are provided with the reactions of the half cell and then the inert value. So always we are going to identify for the inert value which one is the oxidizing agent and which one is the reducing agent. So based on what I said just now, inert value, okay, for the inert value which is more positive, it tends to undergo reduction, so it will be the oxidizing agent. So by comparing the inert value between the magnesium and the silver, this one is more positive, so it will undergo reduction, means that it is the oxidizing agent. Just that simple. And then for this one, it undergoes the oxidation, so oppositely it will become the reducing agent. So in this question, we are going to find what is the overall ionic equation and what is the value of the voltage for the chemical cell. So the answer is, first we just look at the inert value. So in order to calculate the inert value, please remember a formula, which is inert value equals to inert cathode minus inert anode. Okay, so the problem is, some of you maybe will ask, how am I going to find what is cathode, what is anode, since it is not mentioned in this question? So okay, please maybe remember this anode value is always refers to the one that undergo oxidation. So isn't it, we already find which substance will undergo the oxidation. So in this case, it is the magnesium that undergo the oxidation, right? So for sure, here is the reduction. So the inert value would be positive 0.80 minus negative 2.38. So our answer would be positive 3.18 volt. Okay, so we already can cancel out the option which is B and D, because the inert value is wrong. Okay, so let's continue with the reaction to find the overall ionic equation. So in order to find the overall ionic equation, we need to look at and balance the number of electrons. So isn't it, in this question we have the magnesium donates 2 electrons and the silver ion accept 1 electron, but we need to balance it, right? So this is 1, this is 2, so for sure we need to times 2, right? Everything we are going to times 2, so that it will get the same number of valence electron. Okay, here we want to balance, so we want to get the same number of electron. So let's do it. So times 2, 2 Ag plus 2 electron equals to 2 silver ion. So obviously our answer will be C. So this is so when we want to write this, right? So actually it will be Mg, and then become it release 2 electrons, become the magnesium ion with 2 electrons, and then the silver ion here will accept 2 electrons, become the silver. And then actually, just like the mathematics, we cancel out for the same thing, this one, which is the number of valence electron and the number of electron. That's why we need to balance for the equation. So we will get magnesium plus 2 Ag plus, which is the ion form, and then the magnesium will become magnesium ion with the silver. So this is the answer. So the answer would be C. So let's continue for the last 2 questions. So this is a question related to the flowcharts for series of reaction on the salt salt V. So this is from your Form 4 Chapter 6 syllabus. So let's look at the part over here first. So we have the salt V, and then when we heat it, it will become the solid W, brown gas, and the colorless gas X. So we have a reaction 1, so here. Then reaction 2 is like you add the water, and then it will become the salt solution V. So this is just actually like dissolve. It means that the salt is already dissolved in the water and form the salt solution V. So since we get this salt solution V, after that we add a excess NH3 solution, which is the excess ammonia solution. So the observation will be the white precipitate that does not dissolve. Okay, it tells us the color, which is the white precipitate, and it does not dissolve. So this is for the solubility. So after that, when we have this salt solution V, we will react with another solution, which is the sodium sulfate, and then we will get the white precipitate Y. Okay, so this is just the overall idea for the flow chart. So let's see what is correct. Also, we are going to find out the correct pair for W, X, and Y. Okay, so let's highlight the W, X, and Y. Okay, so this is a salt V, and then okay, so okay, let's say we have this salt, and then when we heat it, it will produce the for sure the salt, which is, we can tell it a metal oxide. So the brown gas is actually the nitrogen dioxide. So it will also given out the oxygen gas. So actually X is the oxygen gas. So what is the chemical test that we are going to use for oxygen gas is always the glowing wooden splinter, where if we have the oxygen, so the glowing wooden splinter will ignite. Let's say, for example, this is the glowing wooden splinter, and then the fire may be like this, and then after it gets the oxygen, right, it will like ignite, become a more obvious flame. Okay, so let's go through the column for X first. So actually X, it is produce the pop sound. So first, produce the pop sound lighted with the wooden splinter. This is actually, the pop sound is actually referring to the gas of hydrogen. Okay, so we are not going to find for hydrogen, so our answer will be C or D only. This match our inference just now. Okay, so next, so let's try with the answer, which is the lead sulfate. Okay, so let's say the salt V is lead sulfate. Okay, so it will form the lead oxide, which is the W. Okay, lead oxide, and then this is a heat process. So for information, the lead, it will has a brown solid when hot. So when it is heated, and then when it's still in a hot condition, the solid is actually look like a brown color. So when after a few minutes later, so after it is being cooled down already, so this metal oxide will show the yellow color. So this is the important things that you need to remember for this particular salt. Okay, so okay, we already find the W and X. So next we're going to find for Y, isn't it? So okay, so let's say, so the so the salt solution V is also the lead sulfate. So after it react with the sodium nitrate, right? Actually, they are just changing the place only. Okay, they are just simply change their place, so they will form lead sulfate with the sodium. The sodium. Lead sulfate with the sodium sulfate Na2SO4. Okay, so actually this lead sulfate, basically they will have no reaction. Okay, they will have no reaction because they have the same anion, right? And I think there is a bug in this question because lead sulfate, isn't it? It is an insoluble salt. So I wonder, insoluble salt. So I wonder how it can dissolve in the salt solution and in the water and then become the salt solution V. It's a bit weird. Okay. So this white precipitate is actually referring to this, the lead sulfate. Okay, the lead sulfate. Because it is insoluble in water, it will form the white precipitate, and we know that all sodium salts are actually soluble. Okay, and it also proved that when this lead-2 sulfate is added with the excess ammonia solution, it will become the white precipitate that does not dissolve. So the answer is D. Okay. For the zinc sulfate, it will have another set of the questions. Okay, let's say if we use the zinc sulfate as the salt V. So when this reaction is already go through, right? So zinc sulfate is soluble in water. So this is not valid for it. So this white precipitate Y is not valid for the option zinc sulfate. So our answer will be D. Okay, next, the last question. So this diagram shows us the two chemical cells with copper as the cathode and their cell voltage, inert cell respectively. So okay, we know that our copper is the cathode, right? Okay, it's our cathode. Then we use the copper 2 sulfate solution as our electrolyte. So our anode will definitely be the X metal and the Y metal. So let's see. So this is a experiment for, okay, the diagram 18.1 is the first experiment, and then we have another set of experiment. So we have this set 1 and set 2 to compare the heat of displacement of silver from the silver nitrate solution by method X and Y. So during the reaction, both containers become hot. So it means that the reaction does happen. Okay, does happen. Silver nitrate solution AgNO3. Okay. Which of the following best describe the experiment in diagram 18.2? So actually we are just want to focus on this diagram, but there's the important information, which is the inert value for copper is actually positive 0.34 volt. Okay, so this can be checked. This value can be checked in the checklist in the appendix there. So and then we get the inert value for this is actually very high, right? So we have the inert cell equals to inert cathode minus the inert anode. So actually you can just put the value in lah. Then we can actually know what is the value for the inert anode, right? Okay, inert anode. So I will just leave it to you to calculate for it. So even we don't calculate for it, right, we also can know that for sure this X metal is more reactive than the Y metal, since it has the higher value of the cell voltage. Okay, so let's go through the option. So A, the heat of displacement for set 2 is lower than set 1. Okay, heat of displacement for set 2 is lower than set 1. Yeah, the answer is A, because this is a less reactive metal. Okay, if you want to know what is the metal for the set 1 and set 2, which is the X and Y, you can find, okay, using the calculation that just now you get for the anode, and then you go and find for the match metal, standard electrode potential for it. So B, the temperature for set 1 is lower than set 2. It should not be lower, it should be higher, since the set 1 metal is more reactive, right? So it will for sure give a more reactive, more increase in the temperature. Then C, the heat released to the surrounding for set 2 is lower, okay, because it produces more, the heat of displacement that it produces is very low, so for sure the heat released to surrounding is also lower than in set 1. Okay, and then this is telling us the endothermic reaction. Okay, the energy content for the product is higher than the total energy of content in the reactant. So for endothermic reaction, it is like this. Okay, it is like this. So the answer would be A. So that's all. So we already finished discussing for this trial paper, and I hope you learned something from how to answer in the questions. So I will see you in the next video.